Today we will be doing sections 11.1 and 11.2. We're going to be looking at area formulas for different figures. So we're going to be doing a few activities to discover these different area formulas. First, let's talk about rectangles. You probably learned the area of a rectangle in grade school was length times width or base times height. This is because we know the definition of area is the number of unit squares in a figure. In a rectangle, you can actually count the number of squares because it's filled entirely with full unit squares. However, instead of counting, a more efficient way is to figure how many there are across and how many there are down and multiply those together to get the total number of unit squares. This is why rectangles' areas are length times width or base times height. With that area formula in mind, you're going to do an activity about parallelograms. You're going to use what you know about the area of a rectangle to figure out the area formula for a parallelogram. For this activity, I want you to draw this parallelogram on your paper. Make sure that the parallelogram on your paper is exactly the same size as this parallelogram. Once you have it all drawn, follow these directions and answer these questions. Okay, now that you know how to find the area of a parallelogram, we're going to use that idea to help us find the area of a triangle. I'm going to do a little demonstration for you here, and then I want you to use what you see to come up with the area for a triangle. I'm going to go ahead and draw a general triangle so we can see that the height of the triangle is right here. So this is perpendicular to the extended side of that triangle there. So here's our height, perpendicular to the side, if it was extended out. Now what I'm going to do is I'm going to take that triangle and I'm going to make another one and I'm going to flip that and match these two up. Now what I want you to think about is what kind of figure do I have here with the two triangles put together, and how does that help me figure out the area of each individual triangle? Remember, since I made an exact copy of the other triangle, these two triangles are congruent. Now we're going to talk about areas of trapezoids. So again, let's talk about the parts of the trapezoids. Remember that the parallel sides are the bases. The non-parallel sides are the legs. If the leg is not perpendicular to the base, then it is not the height of the trapezoid. That's very important. Height is always the distance between the bases. The perpendicular distance. Remember, we always define distance as perpendicular. So this length right here, since it's perpendicular to the extended base here, represents the height of that trapezoid. Once again, because we know the area of a parallelogram, we are going to use that to help us come up with the area of a trapezoid. So once again, I'm going to go ahead and build a figure. I'm going to ask you to use that figure to come up with the area formula for a trapezoid. So I'm going to start off by constructing a trapezoid. I'm going to make one of the bases red and the other base I'm going to make green. If you want to follow along with this activity and do it with me, you're welcome to make your trapezoid any size that you want. Once again, this is a general size trapezoid. And then I'm going to make a second trapezoid, exactly the same, but I'm going to flip it upside down. And then I'm going to put it right next to our original trapezoid here. And I'm also going to flip it this way. All right, so we're going to match these two up. Again, remember that the trapezoids are congruent because I made them exactly the same. The red base is the same length in both trapezoids, and the green base is the same length in both trapezoids. So I want you to look at this picture and I want you to see what is the entire figure that we made by putting together the two trapezoids. What is the formula for that entire figure? And how can we adapt that formula to figure out the area of just one trapezoid? Now, I want you to look carefully here because our figure, we can't call that B as the base of that figure. So what we can do is we can call these green bases B1 and these red bases B2. So think about what this entire blue length would be when you're coming up with your formula for the big figure, the area of the big figure, and then think about how that relates to each trapezoid separately. Okay, the last activity we're going to do together is to come up with the area of rhombi and kites. Now remember that a rhombus is a parallelogram, so you can always use the area formula for a parallelogram on a rhombus. But you need to know the base and the height of the rhombus in order to be able to do that. Remember that the angles inside of a rhombus aren't necessarily 90 degrees, so that means the sides aren't always the height of the rhombus. In fact, the only time the sides are the height of the rhombus is when you have a square. Any other type of rhombus, the sides are not the height. And so we may know the base length if we know the sides, but we don't necessarily know the height. So what we're going to look at now is how to figure out the area formula for a rhombus if we know the lengths of the diagonals. Remember, a property about a rhombus is that the diagonals are perpendicular to each other. So if I draw in the diagonals of a rhombus, I get 4 right triangles, and because a rhombus is a parallelogram, remember that those diagonals bisect each other, so I get 4 congruent right triangles. Now if you remember from the activity we did earlier, the area of a triangle is 1/2 the base times the height. So the area of each of these triangles is 1/2, half of a diagonal on the red part, and half of a diagonal on the green part. So let's write that down. If I call the green diagonal D1 and the red diagonal length is D2, then the area of the triangle is 1/2 base, so 1/2 of D1 times the height, or 1/2 of D2. If we multiply that all out together, 1/2 times 1/2 times 1/2 is 1/8 D1 times D2. Now, there are 4 of those triangles. So if I do the area of all 4 triangles, which would be the area of the rhombus, I'll take that equation and multiply it by 4. This leaves me with 1/2 the length of the first diagonal times the length of the second diagonal. Remember, this is the area of the rhombus. Now, because a kite has the same property that a rhombus does, that the diagonals are perpendicular to each other, we can use the exact same formula for a kite. So if we take the length of one diagonal times the length of the other diagonal and divide by 2, we get the area of a rhombus or a kite.